This problem is related to the wave nature of light again. It's based on the n lambda is equal to d sine theta equation, but this time we're asking the question, what's the maximum number of orders that we can see given the particular setup? So in this setup, we've got a monochromatic light source here, we've got a grating here, and then we obviously get a lot of, we get a diffraction pattern here on a screen. And we get the different order images as we go out from the center. This is our straight through position, n equals 0, and then we get n equals 1, n equals 2, n equals 3. And obviously if we kept going out here, we would get n equals 4, n equals 5 so far. And the question is, if we kept going around, if we were able to turn around here and look back at the grating, what would be the maximum number of orders that we could see before we would not be able to see any more orders? Of course, just to remind people that you've also got an n equal 1 image here, an n equal 2 image here, an n equal 3 image, and so on, all the way around. And if we could keep looking around like this until we couldn't go any further, what would be the maximum number of images that we could see? The information that we're given is that the grating here has 80 lines per millimeter. The order of this of the image here is the third order image, and the angle between the straight through and the third order image is 14.8 degrees. So how do we approach this and see, you know, what we can do? Some of this information may not actually be relevant here. So n is what we're trying to find. N is what we're trying to find. We're trying to find the maximum order that we can see. The question is, how many images can we see? But in order to answer that, we have to say, well, what's the maximum order that I can see? Well, obviously, if I start at the 0 position here and rotate a little bit, I'll see a first order image. Then I'll see a second order image if I keep rotating. If I increase the angle, I'd eventually see a third order image, a fourth order image, a fifth order image, and I'll keep going out until I get to a point here where I'm looking at the diffraction grating at an angle of 90 degrees here. And then it's not possible, once you get to 90 degrees, it's not possible to diffract any further. A diffraction grating will not give you a diffraction or an interference pattern back here somewhere. That doesn't happen. So the maximum that you'll ever get will be 90 degrees. So if we put in 90 degrees in here, then that'll tell us what our maximum order is. Now, first we'd have to work out what the wavelength of the light is, because essentially we would be working out n. We'll have the theta already worked out at 90 degrees, and we have d. But we'll need to work out, well, what's the wavelength of the monochromatic light? So let's do that as an example again by doing n lambda is equal to d sine theta, using the information that's given here. So here we're talking about a third order image. This is just to figure out what the wavelength is, right? The wavelength of the monochromatic light. D now, we didn't work out what D was. You might be sort of inclined to put in 80 here, but that's not right. You have to remember that this is 80,000 lines per meter, and then you do 1 over that to get what you get in here for D. So this is 1 over 80,000, right? And then sine of 14.8 degrees. Now, these are the bits of information given in the question. So we're just trying to figure out what the wavelength is first. So this is an example of this. So we can work out what's on this side first if we want to do it in that way. We can do 1 divided by 80,000. Which is going to be, so this is going to be 1.25 by 10 to the minus 6 here, times the sine of 14.8 degrees. This is still 3 lambda on this side. I haven't changed anything. So that multiplied by the sine of 14.8, that'll give me 3.19 by 10 to the minus 7 meters. That's still 3 lambda. So lambda here is equal to this divided by 3, 3.19 by 10 to the minus 7 divided by 3, which is 1.06 by 10 to the minus 7 meters. Okay, so that's what we get as the wavelength of the light that we're using. Now, in order to get the maximum number of orders that we can see, we've now got to use this lambda value in our equation again. So what's the maximum number of orders that we can see? So max number of orders. Well, we said that if we're at 90 degrees, well then theta would be equal to 90 degrees. So we can put that into the formula. Now we're looking for n here in this formula. We're looking for n. So n is the one that we're trying to search for. Lambda we have is equal to d sine, and I can put in 90 degrees here. And the sine of 90 degrees is 1. So that's going to go away. So our formula is going to just become n lambda is equal to d, realistically, because that's just d multiplied by 1. So n is what we're trying to find. We'll get n is equal to d over lambda, if we rearrange it like that. And so n is equal to, well, d we already calculated to be 1.25 by 10 to the minus 6. And lambda we worked out to be this 1.06 by 10 to the minus 7. So if we divide one by the other, we get 1.25 by 10 to the minus 6 divided by 1.06 by 10 to the minus 7. And we'll get 11.79. Right? Now there's no units here because it's order. Order doesn't have units. So we get 11.79. What does that mean? It means that if I was to go along here, I would get an n equals 1. I would get an n equals 2. I'd get an n equals 3 like this. And we keep going out until eventually we get to here and we'd see an n equals 11. And then we wouldn't be able to get, by the time we got to 90 degrees, we wouldn't see an n equals 12. So the maximum number, you can't get 0.79 of an order. So the max number of orders on one side is 11. Right? Is 11. So we can see 11 orders on one side. You can also see 11 orders on the other side. So you can see 22 images just from the diffraction or the interference pattern. And then you've also got the straight through. So that makes a total number of images. Total number of images equals 11 on the left, 11 on the right, and the 0 order. And that gives you 23 images. Okay, hope that helps.